Right, so for this part, we're going to go just 10, 11, 12, and 13. That's it, just these four today, all right? And make sure that you are finding time over spring break or after we come back to make sure you watch these because it's going to be a while since we've talked about it, okay? Remember, the test for this is after spring break, Tuesday and Thursday. Is that right? Yeah, Tuesday, Thursday. And then the day before that, Monday, we'll still go over some more, okay?
Are we going to be doing that?
Yeah, that's fine. All right, so let's do number 10. All right, number 10 is looking for the area of the region in the first quadrant, bounded on the left by this graph x equals y squared over 2, and on the right by this this linear function for y between 2 and 4. So I forgot who it was, maybe it was Eric. Somebody asked, do we always have to graph? And this will be one of those instances where I don't think you need to, all right, because it tells you which one is on the left and which one is on the right. And if it tells you that, you should know that when you set this up, it's always right minus left. Okay? Remember, what is it when we're dealing with the x-axis? Top minus bottom. So hopefully you wrote this down yesterday. So right minus left. So I'm actually not going to graph this one. I'm just going to do the integral from 2 to 4 of the one on the right, which is 3y minus 4, minus the one on the left, y squared over 2, and all of that. And again, it's not a big deal, but this should be dy, right, because with respect to y. All right, I'm going to clean that up a little bit. So 2 to 4, I'm going to put negative 1/2 y squared plus 3y minus 4. All right, let's do the antiderivative for a negative 1/2 y squared, so I know y cubed. One sixth. Let's see, does that work? What's 3 times 1? 3. 3 divided by 6 is 1/2. Yes, that works. Very good, Eric. About for the next one? 3/2. Good, Alex. And then minus 4y. All evaluated at 4 and 2. So let's plug in 4. And we'll plug in 2. Again, this is going to be one of those things where you can do all the right stuff, but make a mistake with the algebra. All right, so there's the first one minus the second one. Okay, 4 cubed. 4 cubed. 64, so negative 64 sixths plus 4 squared. 16 divided by 2 is 8. 8 times 3, 24. Minus 16. Minus 2 cubed, 8, so negative 8 sixths plus 2 squared is 4. 4 divided by 2 is 2. 2 times 3 is 6. Minus 8. What I would recommend doing, since you don't have a calculator, is dealing with the whole numbers first and then the fractions at the end. That's what I recommend doing. So what I'm essentially going to do is, what's 24 minus 16? That's 8. All right, what's 6 minus 8? Negative 2, but we're subtracting a negative 2. All right, so it's going to be plus 2. So that's going to be 10. So my whole number is going to be 10. So you're probably thinking it's going to be A or B. All right, let's do the fraction. So now I have negative 64 sixths plus 8 sixths. What's negative 64 sixths plus 8 sixths? All right, so it is A. Questions on number 10? All right, key takeaways, right minus left. Right minus left.
And the unpredictable have either wrong.
How old is your sister?
7, 8.
That's pretty awkward. And she'll never ask you for help ever again?
The wording was like kind of
Yeah, and you're like, shut up, I can do calculus. There's no time in math when you're at 7. It's just math. All right, let's do 11. All right, number 11. What is the area of the region in the first quadrant that is bounded by this exponential function, the horizontal line, and the y-axis? Now, I don't know if it's clear from this when you read it, but when they say and the y-axis and they don't mention anything about x, notice how they never mention anything about x. When I find this area, I'm thinking in terms of vertical. I'll sketch it for you. I don't think you have to here, but I'll sketch it for you. I think it'll help your brain. Okay. What is 0? When you plug in 0, 2 to the 0 power is 1. What about for 2 to the first power? 2. 2 to the second power? 4. So something like this. All right. And it says the line y equals 4. So that's this line here. All right. And then which axis? The y-axis. So if you look, it's this area here. So really the confusing thing is you need to make sure you get the correct limits of integration because we're going to integrate with respect to y. Okay? So what's this ordered pair was 0, 1, right? What's this ordered pair up here? Actually 2, 4. So I care about the y numbers. So what are my limits of integration going to be? 1 to 4. All right? Now, before I write that, I do have my function, but it's written not with respect to y. So I actually have to change this so it says x equals instead of y equals. So it's an extra step. All right, so I'm going to take the natural log of both sides. What can I do with that x now? I'm just going to say move it to the front, not swoop it. All right, and then get x by itself by dividing by the natural log of 2. So x equals the natural log of y over the natural log of 2. So here's my problem. See if you're okay with this. You see what I did? Why did I do that? Yes, because this is called what? When I move it out there, what's that called? You just took a quiz on it. It's the constant. Very good. I'm using the constant rule. You could leave it, but I'm not going to. If it's a constant, I know it looks a little bit funky because you see the natural log, but the natural log of 2 is just a number. So 1 over the natural log of 2, still a number, still a constant. Move it out front. Make your life easier. Okay? So now, I should have put this one on the form of the sheet. Does anyone know the antiderivative of the natural log of y?
1 over natural log.
No. You're not going to know. It's okay. Y times the natural log of y minus y. It'll go on next year's formula sheet. I took the test yesterday. All right, this is not on there, so no worries. That's why I put this one on the review. All right. No, if you get the AP exam and you're like, oh man, it's the integral of the natural log of x, and you're like, oh, I should have remembered that. Let me know, right? I'll put it on my formula sheet. I mean, don't actually tell me about the test because that's, not okay. But like, yeah, when we go bowling, if we go bowling, you're not allowed to talk about the test. Yeah, not until it's released in July. Yeah, after they release it in the summertime, when I can look at it, then you can talk about it. But until they release it, you cannot. Okay, let's plug in 4. Okay. Can't do anything with this. Do you guys remember the natural log of 1 or the log of 1, whatever the base is? It's 0. Very good, Jonathan. It's 0. All right, so that's going to be 0 minus 1, which is negative 1, but we're subtracting it. Subtracting a negative 1 is really plus 1. All right, so that's 4 times the natural log of 4 minus 3. Now remember, all of this needs to be done, be multiplied by what? Very good. So what I'm going to do over here is do 4 times the natural log of 4 over the natural log of 2 minus 3 over the natural log of 2. Yeah.
It's not like the other problems where we had the two lines and we had to find like the area.
It's not, because there's no space here, so you just have to use the function. Right? There's no space going on in that green area, so you don't need to worry about it. And the other one is what you're talking about from the previous problems is you have two distinct functions, and this one, the reason they gave you this up here was to help you with your limits of integration. All right, now I'm going to do some wizardry that you're going to be like sad about. All right, so just follow if you can. Yep. Okay, I do not have a calculator, and I do not know what 4 times the natural log of 4 divided by the natural log of 2 is. All right, but I can do it with properties without a calculator. Do you see that 4 that is after the natural log? I'm going to rewrite that to be the natural log of 2 squared. Are we okay with that? No, you're not okay with that? I think you are, right? 2 squared is 4. And now what can I do with that 2? Move it to the front, and what does it do in the front? It multiplies. So what's 4 times 2? 8. And then I think you'll see what I can do with my natural logs now. They cross out. So the answer is 8 minus 3 over the natural log of 2. Which is A for Alex. Again, you won't have to do that on the test. All right, it's just another. 2 more to go. These are the ones that I like, though, Alex. I think you're going to like these as well because it gives you the sketch, and all you got to do is set up, right? Just pick the one that sets up the integrals, right? Which is hopefully would be considered an easier one, all right? Because the sketch is there for you. All right. Now, first thing I notice as I move from 0 to pi, right, 0 to pi, is that how many different times are we changing which function is on the top? Twice, right? So a total of how many integrals am I going to need? 3, right? 1 for this one for this area, 1 for that one. Well, only the way the A or B could be okay is if I saw what? Absolute value symbol. Do you see absolute value on A? No. Do you see it on D? No. All right? So now I'm looking at between B and C. And when I notice the difference between those, B just looks like it takes the one that's on the bottom and puts it there, but there's no top minus bottom, right? So Joshua, you're asking about like compared to the other ones. On this one, we should see top minus bottom for each of them. So the only one that does the top function minus the bottom function is going to be C each time. I hope you get this one right on the test. I mean, it's very similar to that. Questions on 12? All right, one more, then we're done. All right. Again, they gave us a figure. That's nice. Appreciate that. What do you notice as you look at that figure? It actually just switches once, right? Well, you're going to need 2 integrals, but it only changes once. All right, so what's my first one going to be? 0 to 2. Which one's on top? The line. So it'll be 10 minus 7x minus x squared. Okay. Plus my next one? 2 to 5.
7x minus x squared.
That one's on top, right?
Yep.
Minus 10. Okay, I'm going to clean them up a little bit. So this is going to be the opposite of negative x squared, which is x squared, minus 7x plus 10. This one is going to be negative x squared plus 7x minus 10. I usually do this when I do problems like this. We don't have to. I usually just look and make sure that all my signs are opposite. Well, that should be hopefully a dead giveaway when you're doing this, and they are all opposite. Okay, what's the antiderivative for x squared? Okay. Minus 7/2 x squared plus 10x. That one's going to be evaluated at 2 and 0. I'm happy there. Plus, now you can kind of just do the same antiderivative, just makes the signs the opposite. So negative 1/3 x cubed plus 7/2 x squared minus 10x. That one's going to be a lot more work because we have to evaluate it twice. All right, try to write small. So 1/3 times 2 cubed minus 7/2 times 2 squared plus 10 times 2. So I'm going to get that number. Plus negative 1/3 times 5 cubed plus 7/2 times 5 squared minus 10 times 5. All of that minus times 2 cubed. Okay, wow, that's a lot. Shouldn't you guys giving you guys more room? Sorry about that. Okay, here we go. I'm going to try to do the first one. 2 cubed is 8. That's 8/3. Minus 2 squared is 4. 4 divided by 2 is 2. 2 times 4 is, 2 times 7 is 14. Plus 20. Okay. Plus 125, right? So negative 125 over 3 plus, okay, 5 squared is 25. 25 times 8 is 200, so 175/2 minus 50 minus, thanks, Catherine, negative 8/3 plus, is that also 14? And then minus 20. Okay, so do you remember my advice a couple problems ago? Was whole numbers first. Whole numbers first, and then we'll deal with the fractions. All right, so I'm going to go kind of left to right here. Negative 14 plus 20, that's a 6. Okay, then I've got, I'm just going to do the right side. That's 14 minus 20, which is negative 6, but we're subtracting a negative 6. All right, so subtracting a negative 6 is really addition. So what's negative 50 plus 6? Negative 50 plus 6? Negative 44. All right, so what's 6 minus 44? Negative 38. So if you wanted to pick the answer, right now you could, because that's the only one with negative 38. But let's get the other stuff so you're not just like guessing. All right, let's do the ones with thirds, okay? So 8/3, and over here I see minus and negative 8/3. That's really adding 8/3. What's 8/3 plus 8/3? 16/3. And so I have negative 125/3 plus 16/3. What's that going to be? That's how you get this one, the negative 109/3, right? And then there's no other term with the 2 in the bottom, right? So that's where they get that first term. So I think if you go with the whole numbers first and then go to the fractions, that'll give you the best chance to get it right. That was a lot. All right.